Right, lesson 34 is called Proportions and Ratio Word Problems. Okay, so we should be familiar with the word ratio. We've looked at that already, but the first thing we should probably do is review what a ratio is, and then we haven't talked about proportions yet this year. You may have had that in the past, but we haven't done it yet this year, and so the next thing we need to ask ourselves is, what are proportions and how are they related to ratios? Hopefully they are, since they're in the same lesson. And then how would we use proportions in the solution to these ratio word problems? Okay, so first of all, let's talk about a ratio. And if you'll recall, a ratio is a comparison of values using division. Okay, so for example, we might have a bag and it's full of some marbles, and maybe it's got some red marbles and it's got some green marbles in there. Okay, that looks like a good bag of marbles, and we might want to know, well, we want to compare the red marbles and the green marbles, and we're going to do that using division. So we would take the number of red marbles and then we would divide it by the number of green marbles. So that's the way that we're going to compare the reds and greens, by dividing. So of course we look at the reds. There are 1, 2, 3. So we have 3 red marbles, and we've got 1, 2, 3, 4, 5, 6 green marbles. So the ratio of red marbles to green marbles is 3 to 6. We would read that 3 to 6. And usually we write these things as a reduced fraction, right? So we could divide this by 3 to get 1, and divide the denominator by 3 as well to get 2. So that simplified ratio would be 1 to 2. Okay. So this is a ratio, 3 to 6. This is also a ratio, 1 to 2, and they just happen to be equivalent ratios. Okay. And that's where proportions come in. So a proportion is a statement that 2 ratios are equivalent. Okay. Okay, so if we're looking, this itself, this fraction is a ratio. This fraction is a ratio. But the entire statement here with the equality sign is a proportion. So I hope that you can see the difference. Okay, a ratio is just a fraction, whereas a proportion has an equal sign with 2 ratios. So this is just a single fraction, and the proportion is some kind of an equation, it will have an equal sign in it. So that's how you can tell if you're looking at just a ratio like this or that, or a proportion where you've got an equal sign that's stating 2 things are equal. Okay, so that should be the answer to our question of what is a proportion and how is a proportion and a ratio related to each other. Okay, and so now if we have word problems that involve ratios, okay, usually we develop some kind of proportion to solve those word problems. So let's look at those kinds of things. Okay, so let me see, I've got a problem here. Lucy works as a babysitter. The table shows how much Lucy earns for various numbers of hours that she works. Is Lucy's earnings proportional to the number of hours that she works? Okay, so for something to be proportional, okay, to say that something is proportional, what we would say is that, okay, well, when we write all the ratios, if they're equal to each other, then we have a proportional relationship. So in this kind of a problem, we want to look at the proportion of the number of hours that she works and her earnings. So let's look at her earnings. And the ratio of that to the number of hours worked. Okay. And if we do that for each line of our table, we want to see, okay, it's proportional if we always get the same ratio. If we always get the same ratio, it's proportional. If we don't always get the same ratio, then it's not proportional. Okay, so let's look at this line of the table where the hours worked is 2 and the amount paid is $13. So in this case, the earnings is $13 and the number of hours worked is 2. So we have that ratio. In the next line, the earnings is $26 and the hours worked is 4. So we would look at that ratio. And finally, in the third line, we've got the earnings is $32.50 and the number of hours worked is 5. Okay. Now, do these all represent the same kind of ratio? Well, let's see what this one is equal to with a denominator of 1 so that we can get sort of so we can put all these denominators as 1 and see if they are actually the same kind of ratio. So if we did that, okay, so if we divide this by 2, we get 1. Divide this by 2, well, half of $13 is $6.50. Okay. So here on this one, let's go ahead and just divide this one by 2 and divide this one by 2. So half of 4 is 2 and half of 26 is $13. And so hopefully you can see that is the same as this one. So if we reduce that, that would be a 650 to 1 ratio. And this last one, let's divide this one by 5 and divide this one by 5 so that we can get a denominator of 1. And then 3250 divided by 5. Well, 5 goes into 32 6 times. That's 30. Subtract, we get 2. Bring down the 5. 5 goes into 25 5 times. Okay, so sure enough, we have 650 here as well. So each time the ratio is exactly the same, 650 to 1, 650 to 1, and 650 to 1. Alright, since the ratio is the same every time, okay, it is proportional. So is Lucy's earnings proportional to the number of hours she works? Yes. The ratio is always the same. Okay, so that's how we would solve that kind of problem. Let's try another one of those. Nelson has a paper route. If he works by himself, the job takes 60 minutes. If he splits the route with a friend, it takes 30 minutes. If 2 friends help, the job takes 20 minutes. Is the amount of time it takes to complete the route proportional to the number of people working? Okay, so the things that we're comparing are the amount of time it takes to complete the route, and we're comparing that to the number of people working. So let's make our little table here. So we've got the time that it takes, and we've got the number of people. If we organize our data a little bit, it might help us. Okay, so the time that it takes, well, if he works by himself, it takes 60 minutes. So it's 60 minutes when the number of people is just himself. It's just one person. Okay. Then if he splits the route with a friend, so there's 2 people working, so we've got 2 people here, then it takes 30 minutes. And then over here, 2 friends help, so there's Nelson plus his 2 friends, that's 3 people. And when there's 3 people, it takes 20 minutes. So we want to make a comparison and look at the amount of time. So time, okay, compared to, and a division relationship, the number of people. Okay, so in this first line of the table, we've got 60 minutes to 1 person. Okay, and in the second line, we've got 30 minutes to 2 people. And then in the last line we've got 20 minutes to 3 people. So are these all the exact same ratio? Okay, well, let's look here. Let's try to get the same denominators, like a 1. Okay, so here, if we made this to 1 person, dividing this by 2 and dividing this by 2, okay, that would be only 15 minutes per person. Okay, so definitely we have a different ratio here than we do here. Well, that's enough for us to tell no, it's not proportional, but we could go down here and go ahead and look as well. Again, if we wanted to make this one per person, just to look at the ratio, okay, well, 20 divided by 3, okay, well, 3 goes into 26 times with 2 left over, so that's 6 2/3 minutes. Okay, so notice that the amount per person is decreasing every time. We're definitely not getting the same ratio every time. So, is the amount of time that it takes to complete the route proportional? No. The ratio is different each time. So the only time we're going to have a proportional relationship is when the ratio stays the same every single time. Okay. Alright, so the next kind of problem that we want to look at solving is not word problems, so these ones tend to be a little bit easier. So we have some ratio equal to another ratio, but one of the numbers in the ratio in one of the ratios is not known, and we want to figure out what x value would make this proportion true, where 2/8 was exactly the same as 10x whatever x is. Okay. So, what we can do on this kind of a problem is sometimes we can almost do this by inspection and look, okay, well, what would make these equivalent fractions? What did I have to multiply 2 by to get 10? Well, here I would have had to multiply by 5. Okay, so if I multiply this one by 5 as well, then I should get whatever x is. So notice I'm just doing 2/8 times 5 over 5. I'm just multiplying by 1. That's the identity property of multiplication that says if I take any number and I multiply it by 1, 5/5 is just a fancy way to write 1, then I will get something that is equivalent, 10x. Okay, so I'll get 2 times 5 is 10, and 8 times 5 is 40. And so we see that x is 40. Okay, so that's written out in lots of steps, but you would probably just say, okay, I have to multiply this one by 5, multiply this one by 5, 8 times 5 is 40. You'd probably just write down x equals 40, but this shows that I'm just using the identity property of multiplication in order to justify that I can say that x is equal to 40. Now, this kind of a problem is not quite so easy to do like we did over here, because I've got a missing x, and so if I ask myself, well, what do I have to multiply 12 by to get 16? Not so obvious. Like if I multiply 12 by 2, I get 24. 12 by 1 is just 12. So it's something between 1 and 2. So this one is not as easy to just figure out, like this one where I just say, well, what do I have to multiply by? Fortunately, we can use something called the cross product. So the cross product property tells us that if we have one ratio, A over B, and that's equal to another ratio, C over D, then if we take here, we go crosswise and multiply A times D, we will get exactly the same thing as if we go the other crosswise, B times C. Okay, so notice we make a little cross in here. So if we take the product of this A times D and the product of this B times C, we go crosswise, we will get the same values. So applying that property up here, we know that if we take 3 times 16, we will get exactly the same thing as if we do 12 times x. Now I'm going to encourage you to just leave it as 3 times 16. Don't multiply that out and get a big number. Okay, often it's a lot easier to solve these if you stay with the smaller numbers. So to solve for x, we know that we're going to have to divide this side by 12 and divide this side by 12 as well. Okay, 12 divided by 12, this will just cancel to be a 1. This will cancel to be a 1, and we'll have an x on this side. And now here, well, if we divide this by 3, that's 1. Divide this by 3, that's 4. And now the 4 can cancel with the 16. 4 goes into there once, and 4 goes into here 4 times. So we're just left with 1 times 4 over 1, or just 4. Okay, so notice, if you just leave this as a product and don't multiply it out, often the canceling is a lot easier to do because you don't have to work with such big numbers. Okay, so you don't need to multiply it all out. Alright, so let's look at a few of the problems from the practice set. It says, which pair of ratio forms a proportion? And then part B, how do you know your choice is correct? We're just going to kind of address those two problems together. Alright, so first of all, let's look at A. Okay, do these form a proportion? What they're asking us is 3/6, is that equal to 6/9? Okay, well, here to get from 3 to 6, we had to multiply by 2. If we multiplied 6 by 2 as well, we would get 12, not 9. Okay, so these are not equal. So 3/6 is not equal to 6/9. So we do not get a proportion for part A. Okay, so that's one way that we can check. Alright, 3/6, is that equal to 6/12? Okay, here we multiply by 2. 3 times 2 is 6. If we multiply this one by 2, we get 12. Okay, that's exactly what we wanted. 3 times 2 is 6. 6 times 2 is 12. So these are indeed equal. Yes, 3/6 is equal to 6/12. So this one works. This is proportional. Okay, and I'll show you one other way that we can check. So if we want to know, is 3/6 equal to 6/3? We could also use the cross product to check. So we could just go on the cross product. Is 3 times 3 equal to 6 times 6? Well, here 3 times 3 is 9. Is that equal to 6 times 6, 36? No, 9 is not equal to 36. So this one is not proportional. Okay, so once again we can use the cross product to check if something is proportional, or we can just use the we multiply by 1 in a fancy form of 2 over 2 and see if we can just multiply the numerator and the denominator by the same thing to get an equivalent fraction. So either one of those approaches will work. Okay, now if we go on and look at C, D, E, and F. Okay, we'll start with C. So there's basically, you have two ways. We can say if we can multiply the numerator and the denominator by the same thing, or should we use the cross product? Okay, so determining which way you want to go with this, you just look, okay, I need to solve for C. Is there any relationship, easy relationship between 6 and 18? So in this case, yes, there is. I can just multiply this by 3. 6 times 3 is 18. So if I do the same thing, and I multiply this one by 3, 4 times 3 is 12, so C has to equal 12 for this one. So that's the easy way to solve C. D, I'm going to let you solve by yourself, but hopefully when you look at this, okay, D is the thing I don't know, so let's look at the numerators that I do know. Is there a relationship between 9 and 18? Yes, it's easy to multiply 9 by something and get 18. So you can solve D a similar way to how we solved C. But I'll let you guys do that on your whiteboards. Okay, looking at E, okay, E is what we don't know. Okay, so let's look at the denominators that we do know. Is there an easy multiplication relationship between 9 and 15? In this case, no. 9 times 2 is 18, that's too big. 9 times 1 is 9, that's too small. So there's no nice integer that we can use there. So on this one, because there isn't a nice multiplier, what we probably want to do is use the cross product. So we know that 15 times E is going to be the same thing as 9 times 5. Again, I wouldn't bother multiplying it out. Just leave it as 9 times 5 so that we can do easy math. Alright, to solve for E, we're going to have to divide both sides by 15. Those cancel out and we'll just have E. And over here, 5 goes into 15 3 times. And 3 goes into 9 3 times. So our final answer is just 3 over 1, because that's just left with a 1, or 3. Okay. So E is 3. Alright, and then F, hopefully you can see the numerators that I know. Can I easily multiply 4 by something to get 3, or 3 by something to get 4? No. There's no integers that's going to work. So again, for F, you're going to want to use the cross product to solve for F. And again, I'll just let you do those on your whiteboard and check that you are good at doing those. Okay. Next we'll look at I. The ratio of the length to width of a rectangular room is 5 to 4. So let's write that down. So length to width equals 5 to 4. So that's how we would write that ratio. If the room is 20 feet long, how wide is the room? So we're looking at a proportion. So we know the length, it's 20 feet long. The length is a numerator, so that 20 is going to be the known value that we put in the numerator. But we don't know how wide it is. The width is the denominator. So that's our variable. That's the thing that we don't know. Okay, so now we have this proportion, 5 over 4 equals 20 over W. And we have to just figure out how to solve that. Well, this is one of those easy ones where we just have 5 times 4 is 20. So we can do the same thing in the denominators, multiply by 4, and then we'll get that 16 equals W. And of course, we should put units on this, so 16 feet is the width. Okay. And then J. The teacher-student ratio in the primary grades is 1 to 20. If there are 100 students, how many teachers are there? Okay, so they're talking about the teacher-student ratio. So we have the teacher to student ratio, and they told us that it's 1 to 20. So teacher to student is always equal to 1 to 20. So there are 100 students. Okay, students is a denominator. So our 100 is going to go into the denominator. How many teachers are there? That's what we don't know. Teachers are in the numerator, so that's where our variable, the thing that we don't know, is going to go. Okay, now there is a nice, easy multiplying relationship here, but just to practice, let's use the cross product. So 1 times 100 has to equal 20 times t. So if we divide both sides by 20, those cancel and we'll get t. And we have 100 divided by 20 is 5. So I guess we should put 5 teachers. Make sure we put our units in there. Alright. Alright, so hopefully you should be able to work on the practice problems that I left for you, D and F, as well as, let's see, G and H. So you can do those on your whiteboard. And enjoy.